We're going to go ahead and take a look at inverse trig functions. Inverse trig functions undo sine or undo cosine or undo tangent so you can find your angle. So any inverse trig function is just representing an angle that you're trying to find. Now, you can write sine to the negative 1, or you can write arc sine. Arc sine, sine to the negative 1, both mean inverse sine. Arc cosine or cosine to the negative 1 mean inverse cosine. Same thing with arc tangent and inverse tangent, or tangent to the negative 1. They mean inverse tangent. Now keep in mind, for these to be functions, inverse sine is defined in quadrants 1 and 4, along with inverse tangent. Now, according to what this is saying, it says if you have an angle in quadrant 4, you need to start at the positive x-axis and rotate down. So let's go ahead and take a look at that. Because it's saying from pi over 2 to negative pi over 2 is what your angles are for your answers. So we're going to start here. If you have an angle in the first quadrant, you're fine. You just rotate up to it. However, if your angle's in the fourth quadrant, suppose you were down here, you would not want to rotate all the way around because it says you can't go past pi over 2. If you're in the fourth quadrant, you have to start here and rotate down to that angle, and it would be a negative angle. Because according to what it says here, it's from 0 back to negative pi over 2, or 0 to positive pi over 2. Now, if you're dealing with inverse cosine, that's just quadrants 1 and 2, and you don't have to be concerned about rotating backwards. So here, we need to solve these. To solve them, you need to get x by itself. So you need to undo sine. To undo sine, I would need to take the sine inverse, or arc sine, of both sides. And I would get this. This is just representing an angle. Now, this one here we don't need a calculator with because you're supposed to have memorized. The sine of what angle is root 2 over 2. And remember, you got to limit yourself to looking only in quadrants 1 and 4. Well, in quadrants 1 and 4, where is sine positive root 2 over 2? And it says in degrees, we're going to say 45 degrees. Over here, we're dealing with inverse cosine to be able to solve this because you need to undo cosine. So inverse cosine or arc cosine, and that's going to tell us our angle. But once again, this is one you're supposed to have memorized. When is cosine equal to root 3 over 2? And remember, cosine is in quadrants 1 and 2. So in quadrants 1 and 2, where is cosine equal to root 3 over 2? And that is at 30 degrees. Here, we need to solve this one in radians. It's an inverse sine or arc sine, which means it's representing an angle, some unknown angle. Now, it might be easier for you to think of it like this. It means the sine of some unknown angle is root 2 over 2. And you need to limit yourself to quadrants 1 and 4. So where in quadrants 1 and 4, because it's inverse sine, is sine equal to root 2 over 2? And that is pi over 4. We're writing down pi over 4 versus 45 degrees because our directions up here say in radians. Looking here, oops, just a second. So this part right here is an inverse trig function. Any inverse trig function represents an angle. So we have our angle here. So we really have the tangent of an angle. The parentheses is representing our angle, but we don't know what it is. But as you look in the parentheses, it's the cosine of some unknown angle is equal to 5 over 4. That's really what we're dealing with. Cosine. So what's in the parentheses means the cosine of some unknown angle, and I'm calling my angle x, is 4 over 5. That's not one you're supposed to have memorized, so I'm going to draw myself a right triangle. Remember, inverse cosine is defined in quadrants 1 and 4. And the cosine's positive, so that means it has to be in quadrant 1. cosine, remember SOHCAHTOA is adjacent, so that's got to be the 4 over my hypotenuse, which is the 5. So now I could use my Pythagorean theorem to get my missing side. So 5 squared minus the 4 squared inside of my square root, it would be the square root of 9, which is 3. So I get my other side to be 3. So this whole inside represented an angle. All I did was draw that angle. Up here I said I'm taking the tangent of that angle, which I called x. So I drew angle x. Now I need to take the tangent of that angle. So the tangent of angle x, remember tangent is opposite over adjacent, is just 3/4. This one here, you want to work from the inside out. This is representing an angle, and it means the tangent of one angle is √3/3. Now, supposed to have that one memorized. When is tangent equal to √3/3? And that answer is pi/6. Then we didn't do anything with what was on the outside, which was sine, so that's still there. Sine of pi/6 is another one you're supposed to have memorized. It's the sine of 30, which is 1/2. Also over here, you work from the inside out. Tangent of pi/4, you're supposed to have that memorized, and that is tangent of 45, which is 1. We didn't do anything to the inverse sine, so now we want to go ahead and do that. This means the sine of some angle is 1. Well, sine of what angle is 1? And that is pi/2, or 90 degrees. If it does not specify what it wants for units, you can put down either one. Here, you're asked to go ahead and write this in an inverse trig function. Well, what am I going to do to undo tangent? I have to then do tangent inverse. So I take the tangent inverse of tangent, and that gives me, they cancel out, giving me A. And then I'll do the tangent inverse of B. And so I have my inverse trig function.